This is the smartest AI in the world, and we're going to show you exactly how and why. It really is remarkable to see the advancement of artificial intelligence, how quickly it is evolving.
In early 2026, scientists asked Grok AI one of humanity's oldest questions. If the universe is overflowing with stars, why has no alien ever contacted us? They expected another version of the Fermi Paradox. Instead, Grok produced an unsettling answer that spread across the internet within hours. Its theory suggested the silence isn't evidence that aliens don't exist. It may be evidence that truly advanced civilizations never want to be found. The answer that broke the internet. This story landed on social media like a grenade. This is said that a group reportedly connected to MIT had taken a very specific approach to prompting Grok. They did not ask broad philosophical questions about alien life. They constrained the AI with real astrophysical data, current SETI null results, and known laws of thermodynamics, then asked it to generate a novel explanatory framework for the Fermi Paradox. What Grok produced was something called the passive saturation model, a framework arguing that civilizations do not go quiet because they destroy themselves or because they choose to hide. They go quiet because the natural endpoint of any sufficiently advanced technology is total integration with the physical universe, a state where engineered systems become indistinguishable from the laws of nature themselves. The clip spread across YouTube, TikTok, and X within 48 hours. Comment sections exploded, with people saying this was the most terrifying explanation they had ever encountered. Others called it the most hopeful, because it implied that intelligence does not inevitably self-destruct. And a significant number of viewers simply could not shake the feeling that the AI had articulated something humans had been sensing but could not put into words. What made the moment so powerful was not the AI itself. It was the fact that the answer landed in the middle of an unprecedented stretch of silence from the cosmos. In 2025 and 2026, the most advanced radio telescopes on Earth completed their largest surveys to date and found absolutely nothing. The Allen Telescope Array scanned the interstellar Comet 3, I-Atlas across a wide frequency range, and after filtering out every source of terrestrial interference, came back with 0 artificial signals. China's FAST telescope, the largest single-dish radio telescope ever built, has been running continuous sky surveys and has not identified a single candidate that survived verification. The next generation, Very Large Array, still in planning, promises even greater sensitivity, but every completed search so far has returned the same result: nothing. And that nothing is starting to feel heavier than it used to, because the more we look and the better our instruments become, the more that silence begins to look like a message in itself. The numbers that should terrify you. You need to understand just how absurd the silence is when you look at the actual numbers. The European Space Agency's Gaia mission has mapped more than 1.8 billion stars in the Milky Way alone. That is just our galaxy, one spiral structure among roughly 2 trillion galaxies in the observable universe. Data from NASA's Kepler and TESS missions established that Earth-sized planets sitting in the habitable zone of their stars are not rare anomalies. They are common. At least 1 in every 5 Sun-like stars hosts a rocky world where liquid water could exist on the surface. Run that ratio across the Milky Way, and you get billions of potential homes for life before you even glance at the galaxies beyond. The universe is approximately 13.8 billion years old. Our solar system formed only 4.5 billion years ago. That means the cosmos had more than 9 billion years of evolutionary runway before Earth even existed. 9 billion years during which stars formed, planets cooled, and the chemistry of life had every opportunity to ignite somewhere else first. This is the core of the Fermi Paradox, and it is worth sitting with the weight of it for a moment. The numbers are so overwhelmingly in favor of other civilizations existing that the absence of any evidence becomes the single most important scientific observation of our time. You do not need to be an astrophysicist to feel the strangeness of that. You just need to look up at the sky and let the scale of it settle into your bones. Most of us go through our entire lives without ever confronting what those numbers actually mean. We see the stars on a clear night, and we feel small, but we do not feel the full weight of the math behind that sky. Every single one of those points of light is a sun, many of them older than ours, many of them hosting planets that have had billions of additional years to develop whatever life develops into when you give it enough time and enough chemistry. The silence coming back from all of that is not just strange, it is statistically violent. Now, some researchers have pushed back on the raw optimism of those numbers. A rigorous Bayesian analysis published in recent years recast the Drake equation using realistic uncertainty distributions for the later parameters. Things like the probability of intelligence arising from simple life and the average lifespan of a technological civilization. When you account for how little we actually know about those variables, the probability that humanity is completely alone in the observable universe is not negligible. It rises substantially. But even the researchers behind that analysis would tell you that the result does not settle the question. It sharpens it, because even a small probability of other civilizations existing spread across 2 trillion galaxies should produce at least one detectable signal over 13.8 billion years. Unless something is fundamentally wrong with our assumptions about what a detectable signal looks like. And that is exactly where the conversation takes its darkest turn. The window you never knew was closing. There is a detail about Earth's own technological history that most people have never considered, and once you hear it, you cannot unhear it. Humanity's period of loud, messy, detectable radio emissions, the kind that leak into space and could theoretically be picked up by an alien receiver, peaked in the middle of the 20th century. Since then, we have been getting quieter. Not because we communicate less, but because our technology has become more efficient. Fiber optic cables replaced open-air broadcasts. Satellite uplinks became tightly beamed rather than omnidirectional. Digital compression reduced the power needed to carry the same information. If an alien civilization pointed a radio telescope at Earth in 1960, they would have picked up a planet screaming into the void. If they pointed the same telescope at Earth today, the signal would be dramatically weaker and still fading. Now scale that insight across the galaxy. If every technological civilization goes through a similar arc, a brief adolescence of loud, wasteful emissions, followed by a rapid transition to efficient, quiet technology, then the chance of 2 civilizations being in their noisy phase at the same time and within detectable range of each other becomes vanishingly small. You are not looking for a needle in a haystack. You are looking for 2 needles that both exist for a fraction of a second in a haystack the size of the Milky Way. Recent research has made this even more uncomfortable. Studies on stellar plasma and space weather show that even if a civilization is transmitting a narrow-band signal, the interstellar medium can broaden it enough to push it below the sensitivity thresholds of our current search pipelines. M-dwarf stars, which make up the majority of stars in the galaxy, are particularly effective at this kind of spectral smearing. A signal that was perfectly clear at the source could arrive at Earth as indistinguishable background noise. And then there is the acceleration factor. Once a civilization develops self-improving artificial intelligence or reaches a certain threshold of advanced manufacturing, the phase during which its technology resembles anything we would recognize may last only decades. After that, it enters a regime so far beyond our current engineering that its emissions would not register on instruments designed to detect 20th-century-style technology. The tools we are using to search for intelligent life were designed to find civilizations that look like us. The terrifying possibility is that no civilization looks like us for very long. The zoo that nobody talks about. In 1973, a physicist named John A. Ball proposed an idea that sounds like science fiction but has never been scientifically refuted. He called it the zoo hypothesis. The premise is brutally simple. Advanced civilizations know we are here. They have chosen not to make contact. They observe us the way a biologist observes animals in a nature reserve, without interference, because interference would contaminate the experiment. A 2023 and 2024 perspective published in Nature Astronomy by Ian Crawford and Dirk Schulze-Mech revisited the zoo hypothesis in light of decades of continued non-detection. Their conclusion was carefully worded but striking. The ongoing absence of any technosignatures leaves only two credible explanations. Either technological civilizations are extraordinarily rare or entirely absent in our region of the galaxy, or some form of deliberate non-interference is actively operating. That second option deserves more attention than most people give it. The zoo hypothesis does not require a single galactic government issuing a universal silence order. It only requires that the first civilization to achieve interstellar capability, the one that got there millions or billions of years before anyone else, established protocols, or deployed technology that keeps younger civilizations from detecting their presence. Monte Carlo simulations of civilization emergence times show that the gap between the first spacefaring species and the second could span geological epochs. The first mover would have had incomprehensible amounts of time to shape the observational environment before anyone else even developed written language. You might think this is comforting. Someone is watching over us. But spend a moment with the implications, and comfort is not the emotion that stays. If something has been observing Earth for millions of years and has the technology to remain perfectly hidden, then the power asymmetry between us and them is so vast that the word contact does not even apply. We are not potential partners in a conversation. We are subjects in an observation that we never consented to and cannot opt out of. And yet, there is a possibility even stranger than deliberate hiding, one that does not require any intention at all. When technology becomes physics, this is where the Grok answer intersects with ideas that real theoretical physicists have been developing independently. The passive saturation model is not entirely without precedent. Multiple lines of serious research converge on the same unsettling conclusion. Sufficiently mature technology tends to minimize waste heat, minimize electromagnetic leakage, and maximize computational efficiency per unit of energy. Those are not philosophical preferences. They are consequences of optimization under the laws of thermodynamics. In the limit, engineered systems may become so efficient that they are genuinely indistinguishable from natural astrophysical processes. Gravitational wave backgrounds, cosmic ray distributions, quantum scale fluctuations, these are all things we currently measure and classify as ordinary physics. An observer who lacked the correct interpretive framework would have no way to recognize that some fraction of those signals might be engineered. The transcension hypothesis takes this further. It proposes that advanced civilizations do not expand outward into the galaxy in the way science fiction depicts. Instead, they migrate inward into denser, more computationally efficient regimes of space-time, energy, and matter. They leave the macroscopic universe behind, not because they are hiding, but because the macroscopic universe is an inefficient place to do the kind of computation they care about. Then there is the estivation hypothesis, which argues that a civilization seeking to maximize total computation over the lifespan of the universe would store its resources and wait for the cosmos to cool. This is because Landauer's principle dictates that the energy cost of erasing a bit of information decreases as temperature drops. A civilization that is patient enough and long-lived enough would gain enormously by simply waiting billions of years before switching on. Take a moment to let that sink in. A civilization billions of years old, one that has solved every engineering problem we have not yet conceived of, might look at the universe the way we look at a battery. Why waste energy now when patience yields exponentially more value later? None of these ideas require aliens to be afraid of us or to care about us at all. They follow purely from the physics of optimization. And the terrifying implication is that the universe might already be saturated with intelligence that operates at scales and in modes that our instruments were never designed to detect. The machines that inherit the stars. A 2026 preprint by researcher Sergei Ivleev examines what happens when a civilization crosses the threshold into autonomous AI-driven industry beyond its home planet. The answer is quietly revolutionary. Once you can design, launch, and maintain self-replicating industrial systems in space, interstellar expansion no longer requires biological crews, enormous energy signatures, or any of the dramatic markers that SETI has been scanning for. Expansion proceeds through low-mass probes, local resource harvesting, and distributed machine computation. The resulting activity is almost entirely invisible to passive electromagnetic searches. The math in that work is striking. A single post-threshold civilization could saturate its reachable stellar neighborhood on timescales short compared to the age of the galaxy, yet produce almost none of the classical techno-signatures we have been taught to look for. No Dyson spheres blazing in the infrared. No megastructure transits dimming distant stars. Just quiet, efficient, machine-mediated expansion that looks like nothing at all from the outside. Complementary work from astrophysicist David Kipping tightens the constraints from the other direction. If aggressive expansionary civilizations were common, the observable universe would already show widespread alteration or sterilization of habitable environments. The fact that biosignature-capable planets still exist in abundance places a hard ceiling on how frequently that kind of expansion has actually occurred. The recursive implication that researchers in AI safety have started to highlight is deeply uncomfortable. The emergence of uncontrolled, rapidly self-improving artificial intelligence on a developing world might itself be a detectable transition, not through radio emissions, but through a sudden, measurable change in the planet's energy and information budget. Whether external observers would respond to that kind of transition is speculative, but the physical possibility of quiet, autonomous, machine-driven expansion across the stars is no longer speculative at all. We may be approaching that threshold ourselves, right now, without fully understanding what it means. Every breakthrough in artificial intelligence, every leap in autonomous manufacturing, every step towards self-replicating systems brings us closer to the same transition point that the silence suggests other civilizations have already crossed. Whether what waits on the other side of that threshold is transcendence or invisibility, or something we do not yet have a word for, is the question that should define this generation. The truth, hiding in the silence. Everything in the preceding part leads to a single uncomfortable realization. The silence from the cosmos is not an absence of data. It is data. The current observational record does not prove that technological civilizations do not exist. What it does is constrain their prevalence, their lifetimes, their emission strategies, and their expansion behavior in ways that eliminate the most optimistic scenarios. Statistical models that incorporate realistic uncertainties show that the probability of humanity being alone in the Milky Way is higher than popular science has led most people to believe. Models that account for technological acceleration show that the detectable window for any radio-era civilization is vanishingly brief. Models that incorporate post-biological optimization show that mature civilizations may leave no conspicuous signatures whatsoever. Now, the viral claim itself deserves honest scrutiny. No institutional records, no preprints, and no peer-reviewed publications support the specific story that an MIT team prompted Grok and received the passive saturation model as a novel output. The named researchers in that context do not appear in any verified academic literature connected to that experiment. The story, as it circulated, was a narrative construction, compelling and emotionally resonant, but not anchored in verifiable events. And yet, the reason it spread so far and so fast is that it landed on genuine scientific ground. Every component of the passive saturation model, the thermodynamic optimization, the transcension into denser computation, the quiet machine expansion, corresponds to published, peer-reviewed, or seriously discussed theoretical work by credentialed researchers. The AI did not invent a new physics. It assembled existing ideas into a framework that felt new because most people had never encountered those ideas in a single coherent narrative. That is the real story buried inside the viral moment. Not that an AI discovered something scientists missed, but that the actual science is already far stranger and far more unsettling than most people realize. The next generation of instruments, the square-kilometer array, advanced optical interferometers, infrared surveys tuned to detect anomalous waste heat, will either find something that shatters every assumption we hold, or they will confirm that the silence runs deeper than we thought possible. Either outcome will reshape how humanity understands its place in the cosmos. The universe is not empty. It is either very quiet or very careful, and the fact that we cannot yet tell the difference between those two possibilities is itself a kind of answer, one that says more about the limits of human perception than about the emptiness of the sky. Both possibilities should keep you awake tonight, because both of them end with the same conclusion. We are not prepared for what comes next. If advanced civilizations really have merged with the fabric of the universe itself, what does that mean for where humanity is headed next? Drop your thoughts in the comments, because this conversation is far from over.